Hello friends, in today's video we shall see the concept of law of variable proportions. The law of variable proportions is also known as short run production function. Now we know that in the short run there are both fixed factors and variable factors. So by keeping all other factors fixed and by changing only one variable factor, the total output will increase in varying proportions. That is why it is known as a law of variable proportions. Also, the increase in total output is related to change in a single variable factor. That is why the law of variable proportions is also known as returns to a factor. So, in the short run, when more and more variable factors are employed, the total output will increase at an increasing rate, decreasing rate, and constant rate. The law of variable proportions can be stated as when more and more units of a variable factor is employed, the variable factor can either be labor or capital. But it should be noted that there can only be a single variable factor in the short run. So when more and more units of a single variable factor is employed, by assuming that all other factors are held constant, the total output initially increases at an increasing rate, and with further employment of that single variable factor, the total output starts increasing at a diminishing rate and then reaches the maximum possible output, after which further employment of the variable factor leads the total output to fall. Suppose if we take the example of a firm producing jackets, he would require labor, which would be tailors in this case, and capital goods, which would be sewing machines, and raw materials such as clothes, threads, needles, scissors, etc. So here we'll assume that the firm has taken 20 sewing machines for rent and has to pay rupees 10 per day for each of the sewing machines, whereas the firm pays a wage of rupees 100 per day for each of the tailors employed. So here the sewing machines are the fixed factor, whereas labor is the variable factor. The total number of jackets produced with the addition of each tailor is represented in this table. So from this table we can calculate the marginal product as well as the average product of labor. When the firm is hiring the first tailor with the fixed capital of 20 sewing machines, the first tailor is able to produce one jacket, and the marginal productivity and average productivity of that first tailor is one jacket itself. When the firm employs a second tailor, both the first and the second tailor together produces 3 jackets, whereas the addition made to the total number of jackets by the second tailor is 2 units of jackets, while the average productivity of that second tailor is 1.5 jackets. And when the firm hires a third tailor, all the 3 tailors together contributes to a total of 7 jackets, while the marginal productivity of the third tailor is 4 jackets. The third tailor's average productivity is 2.33 jackets. So till the employment of third tailor, the total output is increasing at an increasing rate. But with the employment of the fourth tailor, though the total number of jackets has increased from 7 to 9.4, the marginal productivity has decreased. That is, the fourth tailor is contributing only 2 jackets to the total number of jackets, while the average productivity of that fourth tailor is still higher than that of the third tailor. So here the marginal productivity of that fourth tailor is decreasing because of the fixed factors. All those 4 tailors are working with the fixed factors in the short run. That is why even though the fourth tailor is more productive than the third tailor, still the fourth tailor is able to contribute only less number of jackets to the total output. Now again the employment of the fifth and the sixth tailor leads to the total output to increase, but at a decreasing rate. Here we can see that the marginal productivity as well as the average productivity is declining. The employment of the seventh tailor leads to the production of the maximum number of jackets, that is 11 jackets, while the marginal productivity is close to 0. Now suppose if the firm hires one more tailor, then the total number of jackets produced will decline. Why? Because the marginal productivity of the labor is negative. That is, with the fixed factors, all the 7 tailors have together contributed to the maximum number of jackets that they can produce. So if one more tailor is employed, then the additional tailor has no fixed factors to work with, which is why that additional tailor's marginal productivity has gone to negative. Now if we represent this table in the form of a graph, we get the total product, marginal and average product curves as shown in the graph. So in this graph, till the employment of the third tailor, the total output is increasing at an increasing rate. rate, and the marginal productivity is also seen to be increasing. But when one more tailor is employed, the total output is increasing at a decreasing rate. Here, marginal productivity is seen to be declining, but still the average product is increasing. So that is why that area is known as the irrational zone, the point at which the total output stops increasing at an increasing rate and starts to increase at a decreasing rate is known as the point of inflection, which happens to be here. Further employment of the tailors till the 7th tailor produces the maximum amount of jackets while the marginal productivity is close to 0. And if any additional tailor is hired, then the total output starts to fall, whereas a marginal productivity of any additional tailor will be negative. So we can divide this graph into 3 stages. The first stage shows the increasing returns, that is this portion. The irrational zone can also be included in the first stage. The firm knows that he can increase his output production by employing more and more variable factor. That is why he will not stop his production in the first stage. And then comes the second stage, which is this portion, wherein the total output is increasing at a decreasing rate, whereas a marginal productivity, though it is declining, it is still positive. So the second stage is the ideal stage for production for any rational producer. And whereas the third stage is this portion, wherein the total output is falling and the marginal productivity is negative. So the third stage shows negative returns, and no producer will be producing in the third stage because it's obvious that no producer will want to have negative returns. So a rational producer will produce in the second stage. Another important thing to be noted here is that when more and more units of a variable factor is employed, initially the total output is seen to be increasing at an increasing rate, and the marginal productivity of that variable factor is also seen to be increasing. But after a point, we can see that the total output is increasing at a decreasing rate while the marginal productivity is declining. Explaining this concept by focusing on the marginal productivity, this law is also known as law of diminishing marginal returns. And since the change in total output is explained with respect to change in a single variable factor, this law is also known as the returns to a factor. If you like the video, do subscribe to my channel and share the video to maximum. Thank you.